Keeping a science notebook is an integral part of the work of scientists. In FOSS, science notebooks are more than a collection of notes or worksheets. Science notebooks make student thinking transparent and document their scientific journey. These notebooks become a source of formative assessment data for teachers to make instructional decisions. The Science Notebook chapter found in Teacher Resources identifies 4 components of science notebooks to provide some general organization. 1. Planning the investigation. 2. Data acquisition and organization. 3. Making sense of data. And 4. Next step strategies. When planning the investigation, students typically begin by recording a focus question. The focus question drives the student learning throughout each part of an investigation and engages students with their prior thinking. Additionally, students might develop a procedure or make a prediction. As students work with materials, they collect and organize data. Data might be recorded with drawings, narratives, artifacts, and data tables. Notebook sheets are sometimes used to scaffold data organization. In other cases, students create their own entries. Here, students are using their notebooks to organize data they are collecting as they heat and cool different Earth materials. Students analyze their data during a sense-making discussion. They share notebook entries with a partner or a small group. Students also collaborate to organize and share their data in a class notebook. The class can look for patterns and cause and effect relationships, discuss models, and develop explanations. In their science notebooks, students communicate their understanding as they answer the focus question and construct explanations about phenomena.
When the sun hits the sand, water, soil, and air, the particles speed up and there's more collisions between them.
Does anybody have a way that you could show how they speed up?
You could, like in cartoons, they have the lines behind the characters that they're running. Maybe you could do that.
Next step strategies provide an opportunity for students to revise their thinking based on the class discussions and shared ideas. Students can incorporate new ideas, clarify existing ones, and record their new thinking in their notebooks.
And would you please look at this response sheet? This is an actual student that you don't know, that I don't know, but an actual student. And they wrote this. Read it over, please, silently. What would you add to complete it? What would you change to correct it?
The original student was describing a lunar eclipse, not a new moon, and a new moon is when the sun is shining on the opposite side of the moon than from our vantage point, and we're not able to see it, but it's not when the Earth casts a shadow on the moon, because that's a lunar eclipse.
What is one thing that could be written down either as completing or correcting?
That I do not agree with the student,
Okay,
because they're describing a lunar eclipse.
awesome.
I agree with because what the student should have put is that the new moon occurs when the sun is facing towards the side of the moon that is facing away from the Earth. So we can't. So the moon is not illuminated and facing us.
Science notebooks are tools for students to develop scientific concepts and practices, as well as scientific language. Notebooks provide a history of learning experiences and models about the natural and designed worlds. For educators, notebooks serve as a glimpse into the minds of young scientists to enable us to help guide student learning. The Investigations Guide provides teacher supports for student notebook use during each lesson. A notebook icon calls attention to steps when notebooks are used. Notebook masters can be printed for duplication or displayed on FOSS Web. As a FOSS teacher, you can find additional support in the Science Notebooks chapter. Further support can be found in other teacher resource chapters on FOSS Web.